Hi everyone. All right, in this video I want to go over on how to write the claim when we're dealing with matched pairs. So in my last video I went over the matched pairs. So by now if you watch that you know what matched pairs are. But sometimes it's confusing which claim to use. So when we deal with matched pairs, we have three types of claims. So please watch the previous video on matched pairs and you'll see what I'm talking about, because on this one, I just want to go and share with you how we can, which claim to pick in what situation. So the three claims, of course, mu sub d equals to 0. That's for HO all the time. That doesn't change. And H1, that's what we're gonna concentrate on. When do we take the first one, mu sub d equals not equal to 0, two-tailed test, mu sub d is greater than 0, right-tailed test, and mu sub d is less than 0, left-tailed test. I think with the following examples, you should be able to understand this. So let's go over this. Is our class effective for all students? So time is the population. If I want to know the class I teach is effective for the class itself or for a sample, then I can take some examples or some students and give them a final the first day of the class. And what happens, those students, they go through a training, or they take the class. And what is the training is doing the homework, lectures, exams, and all that. And once that's done, I give the students a final the last day of the class. And of course, if we want to know if it's effective, we compare the results before and after the class, which is the treatment in this case. Now I said if you wanna, the first thing you do, you calculate D for every individual student, and that's before minus after, always before minus after. So let's see what we have here. Let's say I have a student in my class, I gave a final the first day and that student got a 10 out of 100, and the last day of class, going through the class, taking all the exams, he or she takes the final and gets 100. So the difference is negative 90. Second student gets 20 the first day, 50 the last day. The other student gets 40 the first day, no change, 40 the last day. So here it's 0. There is another student who takes the class. The first day, he or she knows a little bit of statistics, gets 60 and gets confused in the class. And the final day, she or he gets 50. So here, 60 minus 50 is positive 10. And the last one, 20 and 80. So we kind of understand these are the test scores before and after taking the class. Now let's see what happens in individual basis. There is an improvement here. So the class was effective for the first student, and the difference is 90. So in this case, when the difference is 90, that means it was effective for that individual person. It was effective for the second person because negative 30, not effective for the third student because it's 0. And here it's not effective whatsoever because the difference is positive. And this one, there is an improvement. So the difference is negative. So it was effective. So, and I wrote that for you. E stands for effective and NE stands for not effective. Look at it this way. It's effective. Just look at the difference, because in this situation, to be effective, the difference has to be less than 0. Was the class effective for the sample? Now, when you look at this, the answer I get most of the time, yes, because most students in the sample have negative numbers. But to answer that mathematically or the right way, you should calculate d bar, which is the average of the differences. If you do that, you get negative 34. So I can say, yes, it's negative. So this was on average, this class was effective for the sample that we picked. The class was effective for the sample, and I wrote it for it because d bar is negative 34 and it's less than 0. It is negative, so it's effective in this situation. Is the class effective for all students? Now, when we go from the sample to population, we know we can't do the calculations. It's very hard to do that, so we have to test the claim. That's where we write the claim. So which claim do we pick? So we want to show that the average of the population is negative, because if this claim takes over and I can show that the average of the population, or the population mean, or mu sub t is less than 0, then I can say, yes, I have enough evidence to support the claim that my class is effective for all subjects. So that's the claim we pick in this case. Now let's see another example. Weight loss program. So there's a weight loss program. We want to know if the weight loss program is effective for the population, and we can say, yes, this weight loss program is effective, and advertise that. So to check that, of course, we pick a sample and we weigh them before and we weigh them after, before and after. So the first person was 200 pounds before, and after going through the program or the treatment is 150. So we see it's obvious it was effective for that person because the person lost 50 pounds. You take the difference, always before minus after. So it's positive 50 and it's effective. In this case, just notice if the difference is positive, then it's effective because it's weight loss. 250 minus 220 is 30 is positive, so it was effective for the second person. A person comes 150, 150, nothing happens, so not effective for this one because the difference is 0. That person comes, it was 170 before and 190 after, so not effective whatsoever, and the difference is negative. And finally, the last person was weighing 160 before the program and 140 after the program, so you can say, yes, it's effective. But please check the sign of the differences. Positive is effective, and I put it for you here, and 0 or negative is not effective. Now, we want to see if this program is effective for the population. To test that, we can't calculate that, but we can test it. So we have to write the claim. Oh, before I go to the claim, we want to know if the program is effective for this sample or these 4 or 5 people. So again, the right way of doing it, you calculate d bar and you get 16. On average, you can say that it's greater than 0. It was effective for the sample. For the population, we can't calculate, so we're going to test. Don't forget, from sample to population, we always test. So we have to write the claim if we want to test it. So HO mu sub t equals to 0. In this case, I have to show, let's go back to our 3 tests. I want to show that the population mean is positive, or if I can show that enough evidence that the population mean will be positive, then it's effective. So this is the right claim to pick. Number 2. So here I wrote it for H of mu sub t equals to 0 and H mu sub t is greater than 0 for H1. And again, the procedure for testing, please watch the previous video. You're going to see that. In this video, I just want to show you how you can write the claim. Now, the question is when we use the first one. So the first one, you have to be very careful when you read the problem. So when you see this, does the treatment have an effect? When we talk about have an effect, That means it can have a positive effect or a negative effect. It doesn't mention if it's effective or not effective. It just wants us to know if it has an effect. When it says it has an effect, then of course you use the claim number 1 or this one, the two-tailed test. Mu sub t is not equal to 0. And that's it. Hope this helps. Please watch the previous video on matched pairs and then watch this one. That way you're going to be able to do all the problems. Thank you, and I'll see you soon.